Hello, welcome everybody. Good afternoon. It's so great to see so many familiar faces and also new faces joining us today for HCDE's Distinguished Lecture Series. So for those of you who haven't had the chance to meet, my name is Julie Keats, and I have the privilege of being Human-Centered Design and Engineering's Department Chair, and I get to kick us off today. So if you don't know much about HCDE, our work is rooted in the fundamental commitment to how human values, needs, and lived experiences should shape technology. We bring together researchers, designers, and engineers to explore how systems can be designed to empower communities and improve lives. So today's event is a perfect reflection of that mission, bringing us together to spark innovative conversations at the intersection of technology, critical design, and social impact. So before we dive in, I have a special thanks I want to give so that we recognize the vital support that brings us all together today. So this talk would not be possible without the support of Judy Ramey and Stephanie Rosenbaum, who are here today. I'm so grateful. So your commitment to HCDE has been amazing. This is our fifth distinguished lecture that you've been able to help us bring out and support. And so we're so grateful to all you do for the department. So I also want to note that immediately after this reception, or sorry, immediately after this talk is a reception. So I hope you'll stick around. We'll have some food and a light food and drink set up as well. So you can hang out, interact with the speakers, interact with our lovely donors as well too. If you'd like to get a chance, say hello and build community. Because in addition to this being a distinguished lecture, it's also an opportunity to come together and have some great conversations following our speakers talk. So with that, it's an important thing when I have to intro the introer. So I am going to hand things over to HCD Professor David Rebus.
Thanks, Julie. Hi, everybody. I'm utterly honored to be able to introduce Laura Forlano to you all today. Laura and I have worked together for many, many years, almost our entire career. We got started in sort of a milieu in California back in the day that was called Values in Design. It was these workshops in the mid 2000s or so. Silicon Valley, of course, the place to discuss values, if anywhere. And we ended up not exactly in the same year, but sort of like hanging out in the same spaces as values and technology was being discussed. How to consider how technologies may or may not have values that reflect our values, what values are being pushed forward. And this theme, then, over 20 years ago that we've been working on this, continues to be sort of a common theme between us, but also, I think, an undergirding theme of Laura's work. And then Laura and I were also working together on a project called Digital STS. Many years later, we put together a series of workshops and eventually a volume, which led to a community forming around the questions of how technologies themselves can or cannot embody the technologies and how do we want to situate ourselves relative to them. I think that you and I along with Yanni Lukhisas and a bunch of other people, ran what we think is the first maker workshop in the field of science and technology studies. And maybe here's something I want to emphasize. Science and technology studies is a field, one that participates in human-centered design and engineering, and it has some overlaps with it. But like I would say, it kind of comes from philosophy and sociology originally. And so having this element of making technologies, of actually having people engaged, like imagine like professors from philosophy and sociology, like having their hands into programming. They were a little wary of doing so. And I think it took a little pushing. Here in human-centered design, I don't think we think about that very much, but some other fields have a stronger wariness towards technology. And so doing this workshop in which there was a lot of making and building going on right there and then in like the early 2000s was a bit edgy. And really what I want to emphasize though is like I think maybe in some ways Laura's work has always sort of like existed at this edge. And so this is something I want to emphasize about Laura's work, but also I think some of our work here in human-centered design and engineering, where being a designer, engaging in the question of design, where it isn't simply like a contemplative activity, it is a making activity, and demands some level of collaboration and demands some level sometimes of service. Sometimes we are a service field in human-centered design and engineering. That sort of means that it's difficult to engage tricky, thorny questions of politics, of human lives and human flourishing. It's not the easiest thing because you're often working with people who you don't agree with, and yet you still must support what they do. That's what service means. That's what collaboration means. It is very easy sometimes to take a very strong position of I will not be political at all, or at the opposite position of I will be so political as to make it impossible to work with others. And Laura has never taken any of those stances. Laura, you've always really, really thread the needle of working on the one hand in ways that are driven by the kinds of values that you want to bring. I encourage you to look up her profile. The range is astounding, from feminism to post-humanism, disability studies, recently cyborgs. And so an enormous amount of like charged topics that Laura always addresses with some level of engagement, never from a distance, but also with some level of like value-driven consideration. So this is enormously impressive. I'm very honored to be able to introduce you, Laura. I did ask her right before this talk whether I was going to step on your toes in any way by saying that you don't refuse anything. And then you said to me somewhere something along, well, there's a couple things I might refuse. And so we'll see. We'll see. There's going to be the threaded needle, as always, with the work of Laura Forlano. Please join me in joining us.
Okay. Thank you so much, David. I'm thrilled to be here. But first, my name is Laura Forlano. I'm type 1 diabetic. Type 1 diabetes is an autoimmune condition that destroys cells in the pancreas and the body's ability to make insulin. You're about to hear notifications from a medical device, a smart insulin pump and sensor system that I keep with me at all times. It keeps me alive. These are just samples of what I experienced during a typical 30-day period. July 1, 4:15 p.m. auto mode min delivery. 4:15 p.m. auto mode has been at minimum delivery for 2.5 hours. Enter BG to continue in auto mode. 8:20 p.m. auto mode has been at max delivery for 4 hours. Enter BG to continue in auto mode. July 7, 6:06 a.m. calibrate now. 7:11 a.m. calibrate now. 8:16 a.m. calibrate now. 8:56 a.m. sensor expired. Insert a new sensor. 9:34 p.m. lost sensor signal. Move pump closer to transmitter. May take 15 minutes to find signal. 9:34 a.m. sensor connected. If new sensor, select start new. If not, select reconnect. 9:39 a.m. sensor warm-up started. Warm-up takes 2 hours. You will be notified when calibration is needed. 11:34 a.m. calibrate now. 11:58 a.m. BG required. 3:49 p.m. alert on low. 4:14 p.m. alert on low. 6:04 p.m. calibrate now. Each calibration is supposed to last up to 6 hours. I've always considered myself to be a very good sleeper, but this tested me. 10:19 p.m. low reservoir, 20 units remaining, change reservoir. July 10, 4:09 a.m. calibrate now. 5:20 a.m. calibrate now. 6:24 a.m. calibrate now. 7:34 a.m. calibrate now. 8:39 a.m. calibrate now. 9:44 a.m. calibrate now. I calibrated at 9:59 a.m. I calibrated at 10:05 a.m. Calibrating is a nice way of saying I have to prick my finger with a needle every 4 to 6 hours so the machine can deliver the right amount of insulin in auto mode. 11:45 a.m. calibration not accepted. Wait at least 15 minutes. Wash hands, test BG again, and calibrate. Well, that felt aggressive. 4:05 p.m. calibrate now. Only a few hours later. That was a nice break. That night, I stayed up and calibrated at midnight. I did not want to be woken up in the middle of the night. Do not calibrate. Sensor update. Status sensor. Time left 2 days, 1.5 hours. 12:40 p.m. calibrate now. 1:45 p.m. calibrate now. 2:10 p.m. change sensor. Sensor not working properly. Insert new sensor. I was taking a nap in the afternoon from 3:30 to 5 p.m. 5:46 p.m. Lost sensor signal. Move pump closer to transmitter. May take 15 minutes to find signal. 6:02 p.m. Possible signal interference. Move away from electronic devices. May take 15 minutes to find signal. 6:18 p.m. Check connection. Ensure transmitter and sensor connection is secure. Then select OK. 6:33 p.m. Change sensor. I didn't change the sensor. I was leaving for an event. July 15, 12:01 a.m. Alert on low. 12:26 a.m. Alert on low. 12:51 a.m. Alert on low. 1:06 a.m. Auto mode minimum delivery. 1:06 a.m. BG required. I ate some glucose gummies. I checked my BG. I hoped this would keep me from getting reawakened during the night. It didn't. 1:16 a.m. Alert on low. 4:31 a.m. BG required. 4:31 a.m. BG required. I gave up. I turned the sensor off for the rest of the night and turned it back on at 10:15 a.m. 10:20 a.m. BG required. 11:01 a.m. Alert on low. 11:26 a.m. Alert on low. 6:36 p.m. Alert on low. 6:57 p.m. Alert on low. 10:41 p.m. Calibrate now. Calibrate now. Alert on low. Calibrate now. Alert on low. Calibrate now. Alert on low. Calibrate now. Calibrate now. Calibrate now. Calibrate now. Calibrate now. All right. So again, thank you so much. It's such an honor to be here. The title of the talk is Designing Consequences on Living Well with Machines. And first, I would really like to reintroduce myself. I'm a disabled social scientist and design researcher. I'm a professor of art and design and communication studies at Northeastern, and I've been studying the social implications of emerging technologies such as AI for over 20 years. And I really want to thank first some of the scholars and friends that I have been very fortunate to grow up with and learn from, specifically David Rebus, Daniela Rosner, and Nassim Parvin. And I've really been learned a lot from them. And it's really so nice to see so many other friends and colleagues here today. And, you know, I was walking across the campus, and you all are really so lucky to have such a beautiful campus. Reminds me a lot of where I grew up, Ithaca, New York, where Cornell University campus is. And it is not surprising that that's why so much exciting work comes out of UW. So in this talk, I promised to share ideas about living well with machines. But now I must confess, I'm actually going to tell you about how I became sick with machines, sick by machines, and sick of machines. So here's a brief outline of the talk. There's 3 sections: designing consequences, living in an algorithmic error, and disabled making and doing. So I wanted to introduce my lab briefly, the Critical Futures Lab, where I have 2 great postdocs, Sasha and Arem, and a number of PhD students, Maria Fernanda, Lee, Asla, and Unju. And how did we get started? Well, my research agenda really started in an elevator in Budapest in 2004. And I was with a senior professor in my field. And he said, "What do you want to study for your dissertation?" And I said, "I want to study the wireless internet." And he said, "You can't study things that don't exist." So at that time in 2004, there were already wireless networks in Bryant Park. There were wireless networks in cafes in Budapest. It's just this person didn't happen to know about that. So I kind of set out my research agenda to study people, things, and societies that don't exist yet. And here are some of the images from my field sites over the years, including the University of Michigan driverless city testbed, the Pratt Future Incubator for Sustainable Fashion, and the Chicago Urban Manufacturing Institute. But really the way that I like to talk about my work is that it is about this meeting of the fields of science and technology studies with the meetings of design and engineering in, sort of what I talk about as critical futuring. And for the last 10 years, I've really been spending most of my time writing and making with my own experience, living intimately with machines, the insulin pump and sensor system that I use to manage type 1 diabetes. I began writing about this topic in 2015, and this was about 2 years after I started using them. And when these systems landed on me, so to speak, I knew that I had a responsibility as a researcher to document my experience living with them. In 2018, the manufacturer introduced a smart system that could dynamically adjust insulin delivery, a development that introduced a series of new questions and urgencies. And in July 2019, upon the invitation of Nassim Parvin and Yanni Lukisis to a panel on AI, I sat down every morning for about a month to transcribe the alert and alarm history from my smart insulin pump and sensor system. And this tiny data set has animated much of the last years of my scholarly writing and making. I've experienced a number of what I consider to be AI harms. At the same time, I'm alive to share some of this creative work with you today. And what you just heard was a data performance about the 4 years of sleep deprivation that I experienced 6 years ago. If you cannot sleep, can you dream? I am a disabled cyborg. My devices are inseparable from my body, my subjectivity, and my politics. I use this term as a constant reminder that it is not only me, but also my machines that are disabled, full of flaws and failures, gaps and glitches, seams and symptoms, errors and omissions, bugs and biases. So in this talk, which I stressed out over for the last month at least, I'd like to contextualize some of the recent writing and creative practice with relevant discussions in science and technology studies, design research, and critical disability studies. And I'll do this through a collage of theories, autoethnographic accounts from my 15 years of experience living with these devices, transcribed machine data, mainstream media reporting, and critical creative making practices, as well as participation in social media groups for type 1 diabetics, discussions with a group that I created in 2024, and conversations with close T1D friends and colleagues. So while to some people, the space of medical devices may seem quite niche, subject to very different expectations, rules, and regulations, I feel that these devices are ways in which, and the ways they're already embedded in the world and in the lives of disabled people, can more accurately be understood as wise canaries in the coal mine, harbingers of assumptions, values, priorities, and norms that have already been put into practice. And the ideas, I should say, the ideas that follow would not be possible without the groundbreaking work of feminist scholars such as Susan Lee Starr, Donna Haraway, and Lucy Suchman. So part 1, designing consequences. We spend far too little time thinking about the consequences of our designs. But with increased automation, complexity, and opacity, there is an urgent need to put these questions at the center of our design and engineering. So here I wanted to just mention 2 books. One, which you may be familiar with, Normal Accidents, and I want to give a little shout out to Sherry Wasserman, who recommended this book to me at least 10 times, and I finally was able to draw on it for this talk. And this work reminds us that failures are inevitable, multiple, and they consist of these multiple unexpected interactions of small failures in complex systems that are tightly coupled. And that's why we need redundancies and backup systems when designing high-risk technologies. And in the examples in this book, the operators take creative actions to intervene in these failures, but the failures still happen. The other book, Rational Accidents, talks about the fact that achieving near perfect reliability in complex systems like nuclear reactors is epistemologically impossible. Aviation safety comes not from perfect design, but from deep continuous learning from a massive volume of real-world failures. Okay, so some examples of we might consider here are, for example, the robot taxis, 100 robot taxis that stalled in Wuhan, China recently. Of course, the series of Boeing Air Max plane crashes, which happened due to sensor error and poor training and a host of other factors. The Chicago red light cameras, these cameras prevented some accidents, but they actually caused more rear end accidents because people were afraid to run red lights. And I'm sorry about that. They're all there. And the recent LaGuardia collision, in which there was a quote that said, "Things like this don't happen because one thing goes wrong. They happen because many, many things go wrong." All right. So keeping that in the back of your mind, I think for the talk will be helpful. Okay. So today it's difficult to view many of the discussions today about things like artificial intelligence, technology, and machines as anything other than explicitly techno-fascism and eugenicism. So for example, in Rua Williams' new book, Disabling Intelligence, it is concerned with, and I quote, "the problems that emerge when so-called AI developers and the public alike do not understand what they're building, what they're interacting with, or how these projects proliferate certain beliefs about who counts as human and which lives are worthy of life." Or, for example, Christina Cogdell's book that talked about how some of the best known early designers of the 21st century were fascinated with Darwinian evolution and were breeding animals in their bathtub, discussing ideal types of human bodies and also the streamlining of cruise ships in the 1930s. And with respect to topics such as, and I'll just, sorry. So with respect to topics such as injury, addiction, bias, and erasure, the only logical conclusion is that our systems are designed to produce these things. So for example, in the book Injury, Lachlan Jane writes, "If we understand human wounding to be a central feature of capitalism, the accident or side effect lens of injury law affects how suffering is both distributed and made legible." And Netta Alexander's more recent book, Interface Frictions, describes the notion of digital debility, the slow and often invisible ways that technologies may harm human bodies. But here we're going to go back a little bit in history, and we're going to talk about the original notion of the cyborg, where I will refer to material from the book that I wrote with medical anthropologist Danny Glabo called Cyborg. So the term cyborg was coined in a 1960 paper by Manfred Clynes and Nathan Klein titled Cyborgs and Space. And this was published in the journal Astronautics. Working against the backdrop of the Cold War and space race against the USSR, Clynes and Klein, a physiologist and a psychiatrist respectively, were trying to figure out how humans could live in space. Rather than engineering large structures to protect humans from the harsh environment of space, the pair proposed augmenting the human body with technology. So in plain language, their cyborg would be made up of seamlessly combined biological and human-made parts. It would extend the capacity of the human body to withstand the conditions of space. The new cyborg would not have to consciously think about using its technological enhancements. It would operate automatically without conscious control, like existing breathing or hormonal systems. And finally, all the parts of the cyborg would work together in a finely balanced system, allowing humans to realize the dream of life in space. They saw the cyborg as a possible next step forward for human evolution. Unlike natural evolution, this forward step would be intentional, human-directed, and technologically enabled. And if we turn to the cyborg in disability studies, so Donna Haraway appropriates this cyborg from its militaristic roots and says that it is non-innocent. And she uses the figure of the cyborg as a way of thinking expansively about the ways in which the boundaries between humans and nature, humans and machines, are artificial, and they are socially and scientifically constructed. And we have inherited these divisions from Enlightenment thinking. In contrast to the ecofeminists that critique technology, Haraway suggested in her Cyborg Manifesto that technology might also be a source of liberation from these categories. And while flawed, cyborg remains an enduring reference for disabled people and disability scholars alike, such as Alison Kafer, Gillian Weiss, Damian Patrick Williams, and Ashley Hsu, who point out that Haraway's cyborg extracts from the lives of disabled people without engaging them directly as such. So, for example, Gillian Weiss argues that the only true cyborgs are disabled people. Everyone else is a triborg. More recently, Joanna Hedva reminds us that the relentless focus on wellness stigmatizes the human experience of sickness. With her sick women theory, she writes, sick women theory claims that it is the world itself that is making and keeping us sick. And I quote, I want to reckon with the twin facts that our bodies are fragile and in need of constant care and support, but that we have built our world as if the opposite were true. The story that tells us that care is only required sometimes and that those who are defined by it, either because they need it or practice it, are less valuable, less human. What does it do when we force disability into the background of our stories as something either bad or bad but useful if it can be overcome, when it could be treated like love, war, coming of age, family, identity, a major subject that is strange, rich, powerful, and necessary to the telling the story of life? What about stories that are enlivened and vivified, not despite illness and disability, but because of them? And now I'll turn briefly to, the social studies of diabetes, which, has focused in the field of science and technology studies on, for example, the ways in which the tight standards of control around blood sugar actually produce the condition of low blood sugar. The use of DIY looping devices, which is kind of like open source insulin pumps, the role of dogs in being attuned to the sensing of low blood sugar episodes with Helen Mialet's work, and the history of pump design, Carrie Rentschler's work, and the way they feel their data. Okay. So diabetes, like many other diseases, conditions, and disabilities, is an invisible disability. Even the devices have been designed to disappear alongside other digital technologies, such as cell phones and earlier examples, such as pagers. While it is technically invisible, there are signs. I often see strangers with sensors, pumps, and tubing exposed, feeling that we are part of a secret society. And in my work, writing about my own experience, my autoethnographic practice, I've used the term intimacy as method to describe my approach. And here's an example of some field notes that were taken in the middle of the night. So here you can see 4:19 a.m. I'm asking, how and why does software become a solution to a medical problem? Or the text must be interrupted as my life has been interrupted. September 11th, 2021, 8:12 a.m. Okay, but I think in order to understand the topic, I'm just going to offer a couple of like T1D basics because it is an incredibly complicated set of technologies, and it's also an incredibly complicated condition. And so I just want to hopefully offer a little additional context around the rest of the talk. So let's see. This is what, you can see the set of devices. There's a sensor. There's the place where the insulin goes into the body there, which it says infusion site. And then there's the pump. That's like a typical setup. But there are, of course, there are also these new systems, which are autonomous or automated systems. So the system that you see there in the picture is what's called a hybrid closed loop system. And the only thing the pump can really do is add insulin to your body in order to lower your blood sugar when it's high or when you eat, for example. But the ultimate goal of manufacturers, not unlike the case of autonomous vehicles, there is this vision of fully automated systems, right? Which we see applied in other areas like autonomous warfare, driverless cars, and in this medical setting as well. So while there are, clearly many benefits of these systems, there are also still quite a lot of limitations. Um, and okay. And keeping in mind that having access to a system like this is considered a privilege because not all patients are considered good candidates for the system, which is obviously, decided on sort of racial and economic lines as well. And there's been recently a shift from measuring blood sugar in terms of a 3-month average, which you get by pricking your finger and sending or getting your blood drawn and sending that to a lab, to what's known as time in range, which is the 24-hour average. And one of the interesting things here is that it puts more power in the hands of device manufacturers that have turned 24/7 surveillance into a measure of good health. So for example, the doctors and the medical system that could just like draw your blood and send it out to a lab, cannot produce 24-hour averages with that data. So this system with a 24-hour average is now seen as a better measure of your health, actually. Okay. And here there are just lists of all the limitations that have been documented, and you can see there's 3 different categories of limitations. I'm not going to really go into the details, but you can see that on the whole we can say that these are beneficial technologies, but they still have a lot of limitations. Leave it at that. So one of the things that living with these systems does is it really attunes us to error or these limitations. So here I basically, for the last year, have been taking pictures of all of the everyday errors, and these include blood sugar related errors, any kind of computational fails, and I have about 300 images, but I only picked a small set of them to make this GIF, to just show the ways in which this kind of cascade of errors that is everyday life with machines. So meaning that because I confront the limitations of my devices so frequently, I then see every interaction with computing and I pick up on those errors. I mean, I think we all do, but it becomes more, it seems more existentially problematic when you can see the ways in which the world is like always falling apart in this kind of way. Okay, but I'm not going to make you watch it more than once. Okay, so the next part of the talk is living in an algorithmic error, and this draws on a recent paper that was published in the Journal of Design. Okay, so T1Ds, type 1 diabetics, using AI-driven medical devices and sensor systems serve as accidental early adopters of what are considered to be helpful, but as I will illustrate, also harmful technologies. Disabled cyborgs can be both more than human, to underscore the relational understanding, and at the same time, dehumanized. So for me, this disabled cyborg identity is relevant both intellectually and as a reminder of the ways in which I hold together human-machine politics by virtue of the labor that I'm constantly doing in the background. And while the medical model of disability locates disability in the patient's body, the social model locates it in the ways in which our social structures, including socio-technical systems and what I talk about as intimate infrastructures, exclude and oppress disabled people. And this is not to overstate the ways in which diabetes, similar to the impact that other conditions have, like chronic illness, chronic fatigue, long COVID, endometritis, actually cause direct pain in the body. And in diabetes, in this case, the body is ultimately destroyed over time, which we might say is also kind of a critique of the social model of disability, right? So it's not only the things out in the world that cause disability, like our own bodies are also causing it. I extend Alison Kafer's work around this disabled cyborg notion to trouble the location of who or what is a problem, or in this case, an error. And my performance traces this experience of living in an algorithmic error, drawing on Mike Anani's work on algorithmic errors. So he writes that we need to distinguish among systems, causes, harms, responsibilities, and remedies whenever data-driven automated systems fail. And he continues, Algorithmic errors are almost everywhere and increasingly frequent, but they're usually hard to neatly categorize into discrete causes and harms. And in particular, he explains that we need to try to understand how and why certain people see an algorithmic event as an error, while others see no error at all, just a system working as it's intended. And he continues, if algorithmic errors are seen as things that people cannot opt out of, that require collective action, and that create new shared consequences, then algorithmic errors become public problems. Turning algorithmic errors into public problems takes work. It means seeing seemingly private individual errors in systems design, data sets, models, thresholds, testing, and deployments, as well as the funding and imagination that birth such systems as collective concerns. So over time, these errors accumulate in human experience, causing a kind of slow, exhausting, everyday microviolence. With thanks to Anna Valgarda at IT University of Copenhagen for introducing me to this term. How many days are interrupted, disrupted, lost, wasted, not only for productive purposes, but for loving each other, listening to music, and even eating peanuts in bed? So with the performance, I aim to bring to life the ways in which the dominant assumptions that are evident in the design of these devices are often incompatible with what it means to live a dignified life and flourish as a disabled person. Disabled people are often deprived of having agency to make decisions about our lives. Perhaps this should not be surprising because disabled people, like other historically oppressed and marginalized people, have been and are still today often included from the very category of what it means to be human. So, for example, in a recent announcement, the US State Department declared that it could deny immigrant visas to people with certain medical conditions, including type 1 diabetes, an obvious example of eugenicist ableism. And in The Future is Disabled, disability activist Leah Lakshmi Pitsina Samarsina writes, disabled people aren't supposed to be alive, take up space, exist. In so much utopian social justice-oriented science fiction, it's unquestioned that in the good utopian future, disabled people don't exist. In fact, a major way ableism works is to erase us from ideas of the future. And she continues, what would a future look like where the vast majority of people were disabled, neurodivergent, deaf, mad? What would a world radically shaped by disabled knowledge, culture, love, and connection be like? Have we ever imagined this, not just as a cautionary tale or scary story, but as a dream? The lived experience of disabled people offers an expansion of our understanding of human difference, not as problems to be solved or fixed, but rather as opportunities for questioning our assumptions as designers and broadening our possibilities for creative expression. So here are a few of the lessons that I've learned during my experience as a disabled person living intimately with machines for the last 10 years. I'm attached to my pump, both literally and figuratively. I'm attached to my pump. I'm attached to my pump by 20 inches of clear tubing, adhesive tape, and a metal clip on the plastic casing. I'm attached to my pump. I must care for it in order to care for it to care for me. This highlights the relational nature of life with machines. Disabled people do not need to be fixed. Rather, they are the fixers of their machines. So in short, there is no such thing as automated. These technologies need round-the-clock care, and there are significant power asymmetries between human and machine. So in my case, out of the 286 alerts and alarms that I received in July 2019, only 65, or about 22%, were about an urgent medical issue that needed treatment. And 221, or nearly 80%, were commands nudging me to take care of the machine. It's functioning, of course, also an urgent medical issue. So as you probably sensed, my experience living with that particular smart system was fraught. These technologies claim to fix the body, but it might be at the expense of degrading the mind. So October 13th, 2020, I get a calibrate now alarm, and then immediately afterward, a low reservoir alarm. I picture myself as a tiny gray city mouse with big ears in a Pavlovian conditioning experiment, waiting for a tasty food pellet. But in this case, I didn't get any reward. When you hate the machine, but the machine is you, you begin to hate yourself. This constant buzzing grates on my nerves and unravels my psyche. I feel harassed and hunted, trained and tracked through the constant nudging and surveillance by the machine. I still have 2 more years to live with this device, according to the warranty agreement of my health insurance provider. Designers of such systems are not merely designing the human relationship, but rather we're designing subjectivity itself, what Anne Marie Willis refers to as ontological design. Yet in the United States, the Federal Drug Administration has asked companies to define what a manufacturer intends the algorithm to become as it learns. This is an effort to reduce the regulatory burden on companies, but also allows for software modifications that may have a very real impact on people's everyday lives. Instead, or perhaps in addition, we might also ask who future users aim to become. As designers, we must think about humans and machines relationally, interdependently, and co-evolutionarily, understanding that both humans and technologies are dynamically changing over time without succumbing to reductive transhumanist fantasies about humans being uploaded into machines. Historian Paul Edwards, discussing the artificial worlds of science fiction films, writes, "These artificial worlds, for example, space stations and cities, may pretend to self-sufficient autonomy they cannot really possess. Though often darkened, they are rarely still. Technological artifacts within the space assist in projecting an underlying electric tension. The flickering fluorescent light, the ringing telephone, the active computer screen, the flashing lights and indicators on a CPU. Sleep is fretful and frequently disturbed." In 24/7, Jonathan Crary writes, "The denial of sleep is the violent disposition of the self by external force, the calculated shattering of an individual." As we know from the work of Matthew Wolfe Myers, our current normative sleep regimes are highly organized around industrial capitalism, and as a result, sleep disorders are pathologized. So over the 4 years that I used that system, I not only developed a genuine fear of sleeping, I also became convinced that when I did sleep, I was sleeping like a sensor in shorter patterns that mimic the system. This illustrates the ways in which humans are shaped and are shaped by our machines. And so as such, following anthropologist Nick Seaver, it makes sense to view AI not merely as a tool, but AI as culture itself. Even if you do not use it, it's already shaping you. Is AI refusal even possible, given the extent to which it is already being used by companies to cram it into every digital product, platform, and interface? Power asymmetries, number 4, power asymmetries also matter with respect to who designs technology and who uses it. Seemingly small modifications have a significant impact on everyday life, which is constantly reshaped around software updates. Echoing Orrit Halpern's testbed urbanism, type 1 diabetics experience the body as a testbed, while at the same time desiring a rest bed, a relief from the exhaustion of living with these systems. And we must contend with frequent sensor errors, constant software updates, and systems that are permanently beta. For example, one version of the smart system that I used took away certain options and made it more difficult for me to eat a pizza, a food that I really happen to like. This suggests the need for greater opportunities for participatory design methods in the development of AI. But while participation is not a design fix for AI systems, it's essential for surfacing different questions about the role of technology and design in the future. And following design justice and disability justice principles, AI development needs to be led by those that are most impacted or most likely to be harmed, according to disability rights organization Sins Invalid. Number 5, social relationships matter a great deal. They're often running in the background, holding everything together when systems fail, and we can use design to sustain and strengthen those relationships. So in the past, I've told the story about the plastic battery cap on my insulin pump that broke. And in this case, the solution was not a DIY fix. I tried super glue or waiting several days for the company to send a new one by FedEx, but the fact that the diabetes trainer that I'd worked with for 3 years before recognized my name and happened to have an extra, which he delivered to me personally in less than 2 hours. In her new book, The Double Bind of Disability, Rebecca Montiglione describes the ways in which disabled people, and particularly those using medical technologies that are sold on the basis of, and I quote, a rhetoric of individual autonomy, independence, and consumer choice, are trapped in what she calls a double bind, which requires personal accountability for managing disability through its prevention, treatment, or cure, while their experiential and embodied knowledge is questioned or dismissed, which is evidence of a strengthening moral regime that demands both responsibility and compliance. Okay. While manufacturers continually offer techno-optimistic promises, I've learned that waiting for the next version of the system is not a solution for me or for the planet. And here we might reference Ashley Shu's notion of techno-ableism, the ways in which companies create things that are not needed or wanted, desired by disabled people. And here's an example of a meme that was circulated in a type 1 diabetes group on Facebook this summer after the introduction of the new type 1D Barbie doll by Mattel. Immediately, the censor error Barbie started circulating. So the problems with these systems may look a bit different, but they persist. And in fact, they'll never disappear because failure is the norm when living with machines as well as living with humans. Yet for liability reasons, we spend a lot of time trying to figure out who to blame when things go wrong. And here's an example of the medical waste. And now I'm actually throwing away an even bigger hunk of plastic every 10 days. And you can see that there in the picture. Okay, so lastly, binary logics might work for machines, but they certainly are not fit for humans. Medical technologies for managing type 1 diabetes promise freedom, knowledge, and transparency about one's blood sugar, but instead our bodies become closed worlds, in reference to Paul Edwards, in which data and information is all that matters, and threats, risks, and attacks become almost self-imposed. Rather than certainty, type 1Ds live with constant uncertainty as we navigate abstractions and live between these proxies. In the data performance, I frequently refer to the alert on low alarm. According to the machine, the number 80 is normal, but the number 79 is too low. So for me, on one side of the boundary, perhaps a beautiful dream, though in my case, it's probably most likely a dream about losing things. While on the other side, several hours of interrupted sleep and a day as a T1D zombie. But don't take my word for it. You can observe many of these things in your everyday life with machines if you know what to look for, what Anna Tsing calls arts of noticing. So should we think about algorithmic error as a new question? I see it as an opening for new design approaches and creative practices. So that brings me to my last section, disabled making and doing. So recently there have been a number of major museum exhibitions about disabled art making practices, including at the Victoria and Albert Museum in London and the San Diego Museum of Art. And here, we might reference Sieber's notion of disability aesthetics. And disability aesthetics refuses to recognize the representation of the healthy body and its definition of harmony, integrity, and beauty as the sole determination of aesthetics. Rather, the disability aesthetics embraces beauty that seems by traditional standards to be broken, and yet it is not less beautiful, but more so as a result. So my response to this experience that I've been sharing with you today has been really to move away from rational arguments and explanations and rather towards more performative, visceral, somatic, embodied, and experiential modes as a way of storytelling about my own experience, as well as a way of understanding myself, my data, and my machines. Let's see, I'm gonna probably skip that. Some of these projects, including I made a bathing suit, a series of robotic sculptures, a zine, and these have allowed me to think about what I call data demons in an article in Leonardo, which are ways of working with data, computation that disrupt and disorient, exaggerate and complicate, confuse and corrupt. And when I did the data performance a few months ago, a design professor commented, "First, I thought it was funny. Then I was frustrated. Then I was mad. Then I was just embarrassed." And so I think, trying to find a way to translate, lived experience into something that can, resonate and like share that experience with a group is sort of where I've been focused in recent years. And the last project I'm going to talk about today is called Human in the Loop. And this is a project that I've been working on with my postdoc, Sasha DeCone. And it is a digitally knit blanket that takes that same small data set that I transcribed in 2019, that I performed, that I put into robotic sculptures, and it knits it into a blanket, complete with the text, calibrate now and alert on low. And this blanket tells the story of the ways in which it's impossible to truly separate human and machine labor. And I'm not going to talk too much about the makings of it, but I'm happy to answer questions. So this is a data physicalization. There are some precedents for this work that have, so one of them is the Janine Antoni's knit or woven project. So in the gallery, this artist actually weaves a blanket and then sleeps under it. Okay. And then on the right side is the Tempestry project, and this is sort of a climate change visualization. And I'll just show you some of the images that we were working with to translate this data set into the blanket. This is kind of mapping the data into the two categories of alerts and alarms, those for maintaining the human and those for maintaining the machine. And then Sasha actually did a series of knit samples by hand. And that was tricky because she was a weaver. So she had to teach herself how to knit again in order to do this work. And then we worked in the Northeastern lab on the Knitterate machine, which is a slightly more affordable, but not home knitting machine. And we were able to knit some of these samples and play with the text. And then here is a close-up of that blanket. And one of the themes that we had was around this idea of comfort and discomfort. So, clearly the stories I'm telling, they play with this idea of, being woken up in the middle of the night. And so wanted to have a visual where the blue is very corally and puckered. And so it looks very soft and cozy. And then the orange is sort of very flat and could be like scratchy. And so we added more and more data to the textile. And of course, wouldn't you have it, that while we were doing our fieldwork in Amsterdam, on this trip, I noticed that my sensor was about to expire at 6 a.m. And in short, the sensor had jet lag. I was still on Eastern Standard Time, but it was not. I'm sorry, it was on Eastern Standard Time, but I was not. So rather than being woken up throughout the night with the countdown to change the sensor, less than 6 hours to change the sensor, 2 hours to change the sensor, 1 hour, and finally 30 minutes, I decided to change the sensor at midnight. And at 2 a.m., my husband heard the pump vibrating with the sensor warm-up complete alert. And at 6 a.m., I began getting the fake lows. The sensor continually sounded the loudest and most aggressive urgent low alarm for 2 hours upon reporting that my blood sugar was 60, which would normally be considered an emergency. So since both the sensor app and the pump required this alarm, this meant every few minutes the app sounded and the pump also vibrated. And this left me really exhausted the whole day that we were in the digital knitting studio doing this field work. And we've been planning this project for 2 years. Around 4 p.m. that day, I was nearly falling asleep and decided to take a walk on a nearby path while one of the prototypes was being knitted. So finally, getting back to the studio that week, we found that there was actually a moth-eaten yarn break revealed. And so we talk about the ways in which The moth ate the yarn, caused the knitting machine to break down as a kind of multi-species entanglement where insects, materials, humans, and machines co-produce this disruption. And to manage the slippery lurex, the team had improvised and adapted to shortages in the yarn. And so we, embraced this breakdown and substituted some other yarn. And so lastly, so this piece, which I was going to go pick up a few weeks ago, but of course the knitting machine was down for a few weeks, so I couldn't pick it up. But it will be installed as part of an installation that is opening next spring at Northeastern's Gallery 360. Okay, so in closing, I just have a few last words. How am I doing on time? Okay, so I talked a little bit about the ways in which the medical model and neoliberal ableism forces this individual management through sensors and pumps. And to return back to Rebecca Monteleone's work in Double Bind, she writes, it's within this CRIP space that generative possibilities emerge, not just in the technology, but also in the reimagining of diabetes as a collective collaborative experience. So within this context of self-management, fostering collectivity itself can be understood as a radical act that is working in opposition to individualistic capitalist systems. So in spring 2024, after many years of isolation, I started a group called T1D for scholars, designers, and artists. And this has now grown to over 30 members across 5 countries. We meet on a monthly basis on Zoom, and we just completed our first collaboration, which is a workshop at the CHI conference on CRIP HCI. And then I wanted to quote briefly Petra Kupper's book, Ecosoma, which talks about disability culture as a felt and an active process, not a thing. Okay, so now in conclusion, I just want to offer, a recap since the talk is quite meandering and might be difficult to follow some aspects. So the question really is not what AI will become, and especially not what corporations want AI to become, but rather it's what we as humans, or who we as humans want to become with technology. What might it mean to crip AI in the field of design, or to view every design project from the perspective of disabled people? How can we live with and live well with machines? How might we expand our understanding of humanity in order to offer alternative ways of imagining AI otherwise, what it's for and for whom? So just, quickly, like, I'm disabled. My devices are also disabled. I'm further disabled by my devices due to these secondary and tertiary consequences, and this is to be expected. And clearly, there's a lot of room for improvement in the medical device space. But here, in the talk, I also introduce, error as a problem, also error as a negotiation, and also error as an opening for creative practice. And lastly, so really moving towards, in order to contend with automation and the social consequences, and especially like the tertiary consequences, we need to develop ways of designing with performative, visceral, and effective aspects. So this might mean, designing with the body mind or disabled cyborg, considering the integration of body and mind and human and machine as interdependent, relational, and contingent. And also this idea of, explicitly designing for solidarity, community, and interdependence. So, who will live with the consequences of your designs? So in closing, to return once again to my own experience with the intrusive alarms that kept me up at night for 4 years, sensors and humans make very strange bedfellows. Someday, in the near future, I'll crawl into bed and cozy up, wrapped in a deep blue blanket knit from my data, and drift off to sleep. If we cannot sleep, we cannot dream. Just a few citations and some of the works that I was drawing on and some acknowledgements, and I think we're ready for your questions. Thank you.